All right, go ahead and do the homework from 1.9, which is numbers 1 through 4 and 6 through 11. Okay. So in exercise 1 through 3, say whether the transformations are rigid or non-rigid and explain how you know. So for rigid transformations, it simply means that you're going to maintain the same size and shape. And then for non-rigid, it basically will change size and shape. So for example, this one would be rigid. It looks like the object moved and was flipped, but it didn't change size or shape, so it's going to be rigid. For number 2, we can see that we had a circular looking shape, and now it's a rectangle or a triangle. And so that would be non-rigid because it changed shape. So non-rigid. This one, it looks like the general shape is the same, but it did change size. And so then that would be also non-rigid transformation. Number 4, an ice skater gliding in one direction creates several translation transformations. Give another real-world example of a translation. So again, a translation is just an example of moving, right? So it's when you're moving and it's a rigid transformation, so you're not going to change your size or shape. And so generally, in the case of the ice skater, they're moving around the ice. So what's an example of moving? Well, how about anytime you're moving your chair in the classroom? You're moving the chair back and forth, or you have a soccer ball and you're kicking the soccer ball around the field, or you're throwing a football. Right? All those would be examples of translations where you're moving an object from one point to another. But again, that's going to be a translation. Okay, and then numbers 6 through 11 says copy the figure onto graph or square dot paper and perform each transformation. So make sure you have graph paper when doing this homework and that you're copying the dots very carefully. First thing we're going to do is a reflection. And like we learned in class, that basically means that these dots, use a different color, these dots are going to be the same distance from this line of reflection, which is line L, right? So if this distance here is 2, then this distance here is also 2. And then if this distance here is 1, then the distance over here is also 1. So it's kind of like you're flipping it across that line or like folding it across that line. And so I'm going to go ahead and just do that. You can almost do it kind of visually here. So you can see the general shape is starting to take form. Okay, and then that's 1 away, 3 away, kind of like that. And then you can kind of do a visual check of if you were to flip that around, would that land on top of the other one? Yep, it would. Okay, cool. So we're going to go ahead and rotate the figure 180 degrees about the center of rotation to point P. And so to do this, I would recommend using patty paper if you have it at home. I have some in my classroom you're welcome to grab because it's a lot easier to do it with that than to kind of calculate it. But basically, you could imagine that you're going to put a pencil right there, and then you're going to trace this figure onto the patty paper and then rotate it 180 degrees or a half circle. And then when you do that, you will get the new figure. One of the things you could do is take this figure and then just rotate the whole paper 180 degrees, and that's going to give you the new one, right? And again, the direction is going to be clockwise in this case. Okay. Then in number 8, it says to translate the figure with the translation vector, right? So I'm going to move everything to the right by 1, 2, 3, right? So 1, 2, 3. My new point will be here. And then this point will be here, and this point will be here, and this point, and this point. And then that is 1, 2, 3. And then you can kind of estimate this little semicircle here. Right? So that's your translated image to the right 3, right? So that's to the right by 3. Okay. All right. With number 9, it says to translate 3 units left and 2 units up. So 3 units to the left, that's 1, 2, 3. We call that P prime. Q, 3 to the left, 1, 2, 3. Call that Q prime. R to the left, 1, 2, 3. Call it R prime. And so that's what led left, but we're also going to move it 2 units up. So let's do that again. So 1, 2, 3, 1, 2. So that would actually be P prime right here. And then 1, 2, 3, 1, 2. That would be Q prime. 1, 2, 3, 1, 2 would be R prime. So again, it should look like the same size and shape, which it is. That's the translation of 3 to left, 2 up. Translate 1 left, 4 down. So 1 left, 2, 3. So there's R prime. 1 left, 1, 2, 3. Q prime, 1 left, 1, 2, 3. P prime, and then just connect them like that. Great. Then reflect across the x-axis. So everything, if it's on the x-axis like P and Q, it's just going to stay there. And then R is 1, 2, 3 away. So 1, 2, 3. So there's R prime. And boom, there you go. That's going to be the reflection across the x-axis. Okay, so again, going back to number 7, you're going to want to do that with patty paper. And when you rotate it, it's going to be somewhere in this area on your, and if we look at the homework solutions for 1.9, there we go. So this is what number 7 is going to look like when you rotate 180 degrees clockwise.